I'm putting in the chat just a question, just because this will help me think about for this session. It looks like there's about 5 or 6 or 7 of us in the room. Just wondering what brings you here for this topic. This is one that's near and dear to me, and so I can get really excited about it. But if I know a little bit about, if it's more of an elementary focus here, if you're more curriculum people and you're not a math teacher necessarily, you're just looking for strategies to help, that would help me. So I'll get set up here and share my screen and all, but I just want to make sure if you can tell me a little bit in the chat what your role is, then that would help me think a bit about, as we talk this through, what that might best be to help you with that. So I'm going to set up my screen here while I'm waiting for that so that I can see what you're saying. So I see someone's 8th grade science teacher. Thank you, Christina. So the topic is about mathematics in particular, although I should say, so I see a high school CTE teacher, awesome, 9th grade math and physics. That's me, Yang, so we're together in that. I have been a science and math teacher for almost 40 years and was particularly the work you're going to see today and the conversation we're going to have centered from some of the work that about 10 years ago, as I tried to do an integrated STEM 9th and 10th grade physics and algebra 2 geometry and life science class. So we were looking at highly integrated project-based work. And that made me as a math teacher back up and really ask questions about, what is it that I really am trying to get to about my mathematics teaching? So I see elementary and 4th grade. So we have a real span here. Everything I'm going to show you today is applicable across that, but please make sure you ask questions in the chat because some of those might be helpful to know sort of how these dissect into some different areas, because even though my excitement and energy is from a little bit older level student, these same techniques and mathematical approaches work all the way down to early childhood work, even though the types of mathematical work you do is different. There's a link here. I'm going to post it right now. This is to get a PDF of the presentation. So it has all of the slides and all of the links that are on them, so that if you saw a tool today that you thought was helpful, you can go in and jump on that. We're going to look at 4 tools. Desmos, Graphical Analysis, GapMinder, and Wolfram Alpha. These are tools that were sort of just in my tool belt with my students, but I've seen them used at all grade levels for different reasons. And some of them people are familiar with, some aren't. So I'm going to make sure we check on that. So we're going to sort of play with these a little bit and see what they look like. But of course, the meta level of this for you is, in what ways might you see this come into your work, or how might you use this? And in particular, with the focus here about what we're talking about when we talk about modeling and visualization. So I want to review a little bit, because we're all been dealing with how we might do these things as virtual techniques, if we've got hybrid classes or online classes. And the beautiful thing about these tools is, because they're technologic and they're either internet-based or app-based on every platform, you can use these with students in virtual learning, in synchronous and asynchronous environments. So they're really powerful. So I want to review a little bit about a model for instructional design that talks about what that looks like for virtual learning, and then why this fits in, this idea of mathematical modeling and visualization fits, and then we'll play with the tools a little bit. But here's your first mathematical question of the day, and I'll explain this a little bit more after I give you a chance to think about it. In my upbringing in mathematics, these were the kinds of mathematical problems I was typically asked to solve. The question that might be the right one we should be asking students is this one. And so here's the challenge I've got for you right now. In the chat, what is the possibility on the left side of that equal sign if the answer is 7? Can you give me an attempt at what's on the left side of this? What representation might give us 7? And I'll give you a minute to go in there and do that. And then I'll explain where I'm trying to go with this. But a little mathematical conundrum for you today. I'm going to cheat and put in an easy one for you. Now you can't take that one. You have to put in something different. Are we thinking with our math caps on? It's hard to tell. Or are we just thinking, someone also put in an answer that works for me? We just came out of a session on formative assessment. And one of the things we talked about in that session was, how do we collect evidence of student thinking and getting a sense of where they're at? Ah, thank you, Jessica. I see a 14 divided by 2. Oh, a 49 divided by 7. Well done, CDS. Let's at least give 2 more opportunities here to see what other people might do to tell us what is the left side possibility here. What we're trying to do here with these kinds of things we're going to try today is push students to a higher level of thinking about their mathematical understanding. Much of mathematics traditionally has been taught as, a word problem, Maria, bravo, that's awesome. Plus, this time of day, brownies sound awesome, so thank you so much for that. There is a whole bunch of activities that are like this. So here's the framework that we're going to, 2 and 2 and 2 and 1. Thank you, Mr. H, I appreciate that. I've given you a link here. There's a wonderful article I read years ago that was on NPR. It was a 2016 that was this researcher that had looked at before the Renaissance. There were actually 3 distinct kinds of mathematics that were part of everyday life for people. There was artisanal math, which is the math that people like shoemakers and architects and shopkeepers used. It was the math that was necessary for them to do their work. And then there was sort of this philosophical math, which was, I'm just curious about what does it mean when we say 1? I mean, that idea of sort of where is that at? And then there was economic math, and that was the math of keeping track of values. And so that was typically with businesses. And then something remarkable happened where mathematics became all focused on this 3rd one. And so the math that we teach in schools, and this article, if you read it, really goes into the history of this, evolved away from useful math that people use in everyday life, or just wondering math, like people that just look at patterns and think, I wonder why that looks like that. And it sort of evolved into this very rote, there's only one way to do it because we're trying to get to the bottom line. We're trying to figure out what our net profit is. And so it took away from really mathematics education, the opportunity for students to play, to create, to see the application of it. And so our challenge as math teachers is to figure out ways to go back to looking at modeling and visualization as one of the means to do that. One of the things as a teacher that I bring into my room are puzzles, because I find them to be really interesting and students love to dig into them. And so I don't know if you're familiar with the website 538.com. Most people see them as a website that talks about political analysis, and Nate Silver and Galen Druk and these folks that do this sort of detailed analysis of, of political campaigns. But deeper underneath their site, they're all statisticians. And so they have marvelous areas where they look at analysis of sports and society and trends in global issues. And there's a section of their website that has a riddler. And it's a nerdy little place where there are prompts for people to sort of do tricky problems. And one of the things that I've always tried to do is open up the possibility that we should be having some fun of using the mathematics we know at all levels to get students to think more deeply about how well do we really understand our math. So just the website to offer you. There's a lot of research over the last 20 years in particular about distance learning. And there's something that I want you to see here that just sort of applies to as you're thinking about how do you support your students in mathematics learning in particular. There's this model that's mentioned by folks like Cole, but it's been applied by Curtis Bonk amongst others, that this R2D2 model, that when we work with students and we get them involved in concrete experiences, when we get them to reflect and to think about what they see or hear, so here's where visualization matters, where we ask them to display. So again, that gets to the visualization aspect of mathematics. And when we get them to do, when we get them to manipulate, predict, come up with ideas, turn an abstract idea into a concrete statement, that those are means by which we're pushing students to move up Bloom's taxonomy scale and to get more into the higher level thinking in their mathematics. And so this idea of mathematical modeling, this is from the Guidelines for Assessment and Instruction for Mathematical Modeling, is it uses math to represent, to analyze, to make predictions. It's the stuff that math is for, right? It's not just, well, I can solve a quadratic equation. Why? I don't know, because I have a test on it on Friday. So how do we continually provide opportunities for students to use, analyze, predict, and do that kind of work? So my hope is over the next half hour, I can show you some examples of that. You know, here's an example of that process. We look at a problem, we make some assumptions about it, we identify the things that we might be able to collect, the data that would be important to gather. We actually collect the data, we do the math with it, we analyze it, we try to reach conclusions, we maybe go back and recollect data because we didn't get it right the first time. And then we've got a model. We think, okay, we think we understand how this works. So I will show you some examples. And at the end of this presentation, I've got a folder that I'll share with you that has examples from 5 years of my work as a STEM teacher who had mathematics and physics and geometry as the sort of mathematical underlying of the ways that I had my students apply mathematics to real world problems and still be able to go back and take the test later on that mathematical subject. So when we're designing, if we're working virtually, we want to get students engaged. And that means we're trying to push them from just simple recall. You know, you think about, again, my experience in mathematics, here's a quadratic equation, here's the FOIL method, do 30 of the same kind of one. That's a very low level remember and understand. What we're trying to do here in this modeling and visualization is push students to analyze, evaluate, create, to really make meaning with their work here. So there's this wonderful thing called the Pedagogy Wheel that unfortunately Carrington has not updated in a few years, but it's still wonderful because he was interested, this is the EdTech side of my world, of how certain applications, so that's what you see in the outer rim of this wheel. This is from 2016, I think the last time it was updated. So there's more there now, but you can see the inner side is Bloom's taxonomy: apply, understand, remember. So green is remember. And then there's the action verbs that are tied to that. The reason I want to show you this is the work we're going to see today fits under those higher level: apply and analyze, tools that do data analysis, tools that do searching of intelligent databases and finding multiple pathways. And so what we're trying to do with this mathematical modeling work is to push students into higher level thinking about their mathematical understanding. So we're doing things like databases and abstracts, and we're asking students to build and diagram and graph. So we're trying to manipulate data in meaningful ways. So the first tool that I'd like to talk about that fits into this framework is Desmos. So can I just see, and this is a way, you can just put this in the chat. So if you would, I'm just curious for you right now, how many of you are familiar with Desmos? Like 5, I use it all the time, I love it. Fist, I don't understand it at all since we're not using our cameras much right now. I'm looking to see, I think we only have a couple of cameras on. Can you just give me a quick read on 0, 2, 1, 5? I see a 2 and 2 zeros right now. Let me give a couple more, because then I'll make sure we put it in the right context. I see CDS has a 5, but I see a 0. So DS, I hope you're okay that we're going to take a little time to just set the frame for what this is and talk about it, but I want to show you how it can be used. So let me tell you a little bit about Desmos. Free. It's a web-based tool, but there's also apps on the Google Play marketplace and on the Apple iOS side. So you can actually have students put this on iPads or Chromebooks and those kinds of things. But what this tool does is it allows you to create mathematical models from data sets or from functional representations. And so if you were to click in to this document here, I just want to show it to you real quick. There's all kinds of resources. If you're a newbie, if this is the first time you've used Desmos, it talks to you about, here are some of the basic things you can do with it. But probably the best way to show you Desmos is to actually have you take a look at it. So let's go and try and do that right now. I want to show you a couple of examples of what my students did with this over the years. So we might just be trying to understand functional representations of quadratics. So what you see here is mathematical play. What we did was we started with a basic function, and then we said, well, what happens if we start playing with adding or subtracting. So you see values here on the left side of functional representations. And so I gave my students an opportunity to create a variety of quadratics to try to get a sense of what do families of functions look like? What does adding or subtracting from the end do? What happens if we subtract versus add? What happens to the center of that graph? Where does the foci go? You see another example here that dealt with inverse functions, and we were looking at them. So this is kind of higher level math. But then you can do amazing things with Desmos. So this was a project that my students did where we were looking at these particular NCTM Common Core standards about representing equations, solving equations, doing inequalities, using relationships. And the students created artwork, and then they mimicked it or they modeled it in Desmos to recreate the artwork in Desmos. And so this is an example of what one of those projects from those students look like. And all these things, if you want to take a look at any of these, this is what that project sheet looked like that required the students to create some art and then go in and create a mathematical model of it so that they could show how they learned their mathematics through expressing their art. So I want to just show you a couple of quick things with Desmos here. So I'm going to jump on here and I'm going to say, we're going to play together. So I want you, if you don't want to watch me play, you should be playing with it or playing along with me. I just put the link for that, since some of you may not be familiar with Desmos, in the chat window. And when you go here, there's a couple of things I want to point out to you. You notice that on this main page, it asks, are you a student or are you a teacher? Because you can create a class within Desmos for your students so that they have access to a particular area and you can monitor and submit work. And then there's a whole set of activities that are built in for teachers that work at all grade levels. So if I were to just click on here for browse activities real quick, and I go into the teacher side of Desmos, I see all kinds of ways in which I can already get into linear functions or middle school geometry or all these different starter information. So there's already built in tutorials. But the quick way to look at Desmos is just to open it up and take a look. So when I go into the graphing calculator, it looks like this. And so there's a couple of different ways I can do my representation here. I can write in an equation like y equals x, and I can just type that in, and it creates that graph as I do it. I might say, okay, now what happens if I add 1 to it? Y equals x plus 1. Oh, so what did that do? So here's where the play part, that sort of, and I look at it as the philosophical part about how does this function work? Why does it work the way it does? What happens if we add versus subtract? What happens if there's if we say y equals 2x plus 1? So I'm just typing these in and I'm getting very quickly cues here. I can turn on and off these functions. I can create families around this. I can do intersections. I can do inequalities. And not only that, you see where it says add item, I can add a table. So I can take data that I've collected and I can put it in here to analyze it. I can put an image on top of this so that I can try to match curves. So in Desmos, there's this really rich world for students to play with. Think about our goal again. We're trying to model data, right? We're trying to create, analyze, represent, create general out of many data sets maybe. And so a tool like Desmos gives us the ability to do that. So that's one tool you might consider bringing into your work. This is not a Desmos workshop, which would be its own thing. The goal here is just to look at some of the tools that are readily available, that are free, that as a teacher that might want to bring in mathematical thinking into your class, ways to do that. So that's Desmos. And I'm going to leave this right now. So we're going to look at these 4 tools. Then we'll have a chance for questions and answers, but I want to make sure I have time to take a look at all 4 of these tools. The second one I want to show you is a tool called Graphical Analysis. And again, can I see in the chat window if you're familiar with this or not? So I'll take a look there while I'm getting you set up here. Graphical Analysis is free. Any teacher or any person can go, and I've given you a link on this document to go there. There's a Mac OS version, there's a Windows version, there's an iOS version, so that students can put it on. I've got it on my iPhone, I've got it on my iPad, I've got it on my laptop. So my students walk around with this tool all the time because it gives them an opportunity to do a couple of things that I'll show you in just a second here. So there's a link here. The tool comes from a company called Vernier. Dave Vernier and Christine Vernier are in Oregon. They were former teachers. And back in the 80s, they started a technology company that supports education. So they sell both the software like this. In this case, they give this one away free. And then you might have seen some of the sensors that measure things like motion or temperature. So this software also allows those tools to be brought in, or that data to be brought in through those tools. But the beautiful thing about graphical analysis is when you go to their website, you can just download it for free. It's freely available so that teachers can use it, even if you don't have any of their other tools. So it's one of those giveaways that they think is so important. So I've already asked you to do the fist of 5. Let me show you a couple of examples of how I've used this with my students. So this is one of my students who's trying to investigate linear functions. And so my students were thinking about how might I collect data that might let me explore when some phenomena, can I represent that in a linear way, or is linear possible with that? So here's one example of a student doing that. Here are some others that students did. Again, I'm going to give you the resource folder. All of these are all homegrown projects that I ran for my students. But the goal here is they had to have a hypothesis that the relationship was linear. And then this is what their data looked like. So they collected data. So these students were seeing if a drop of a tennis ball, and they looked at the bounces. So if I drop it twice as far, does it bound twice as high? So this was their data table they collected. And then they put that into graphical analysis, and they were able to look at the relationship and try to come up with an argument for, does this relationship look linear? So again, we're doing more than just giving students canned data. We're doing more than giving them something that doesn't have error in it. We're trying to get students to really analyze, synthesize, try to build in thinking around what that looks like. Here's another example of a mathematical model that's of a ball rolling down an incline plane. And so again, what am I trying to get my students to do? I'm comparing functions in different ways, algebraically, graphically, numerically. So the students are saying, here's the data, here's what we think the model looks like, the mathematical statement that represents that for predictive use. Here's what the visualization of that data looks like. So in many ways, I'm trying to get students as a mathematician to think the way a mathematician would. What does it look like? What does the trend look like? How do I know this data has real teeth to it if I'm thinking that this is the model? Defend your analysis and explain how you came up with that. There's lots of support for how to use this software if you want to try to bring that in. I actually want to show you what that looks like. So I'm going to stop sharing for a quick second here, just so you can get a quick look at how it looks. It's actually an app, so I can't show it within my window. So I'm going to launch it right now real quick. And then I'm going to go back and share my screen and have you actually share. I'm going to share the app with you. I'm going to share my desktop right now so you can see this because it's riding on top. So I think you should be able to see it now. So think about what you saw with Desmos, which is free and on the web. This is an app, but I want you to see a little bit of how this works. So I'm going to do a very quick so what I'm doing right now is I'm just putting data in a data table. So you can see it automatically graphed it, it scaled it automatically. But the real magic of graphical analysis is that analysis part. So I'm going to swipe across this data set so that I'm analyzing those points. And then I'm going to ask my graph to tell me some things about it. I can add predictions. I can apply a curve fit. I can look at the statistics about this data. So for example, there are 5 in this. The mean is 3. The standard deviation is this. It's interesting when I show this work to some teachers, they say, well, that's not fair. It's doing all the work for the students. But what it's really doing is it's forcing students to think the way a statistician, a mathematician would. Does that data make sense? If I've got error, can I account for it? Why is that third point so far off? You know, does that really look linear or is it an exponential graph? in giving students tools that look like what a professional mathematician would use, what a statistician would use, what an experimenter would use. We're asking them to take on the thinking that that person does. And that's where they start drawing on their models like, well, I think this is linear and here's why I think it is. You know, the regression line came out to this, or the data looks like this. So I think that tells me something about what's happening. So the power of a tool like graphical analysis is it gives us the ability to give, I've seen elementary students use this tool to just make simple graphs, and I've seen high school students do an IB extended project where they looked at battery life of cell phones and looked at where the charge recycle point happened. And there's a mathematical formula that's been determined through research and whether that's true for nickel batteries and whether it stays the same. So from every level, it gives students an opportunity to use mathematics as a way to model and visualize what's happening. So that's graphical analysis. Two more tools to show you, and then we'll go back and take questions here. So I'm going to stop sharing real quick here so I can go back to my presentation. That's the only one that I have to leave what we were doing to show you. So here. Again, just to remind you, all of the links for these are on that URL that I gave you. I'll post it one more time at the end of the conversation, including where the resources are for this. Here's your third tool that I want to get a sense of your familiarity with. This is such an amazing tool. It's hard to believe I see this so rarely used in education. It's called Wolfram Alpha. Can I just get a sense in the chat? Have you ever played with Wolfram Alpha in your work or even just playing with it yourself? What's your familiarity with that? I know, Maria, I saw it a little while ago, you said new to me. If there's probably one tool I'm going to encourage you to take away today, it's this one because of how powerful it is. So I see at least the first couple of responses here. It doesn't look like most people have used this. So what Wolfram Alpha, let me get back to my presentation here, is it's a computational database. What that means is it allows you, it has data sets built into it. It has mathematical thinking built into it. And it has artificial intelligence built into it so you can query it. So I want to show you a quick example of how amazing Wolfram Alpha is. And I'm going to show you a little video about why this tool should be used by every mathematics class from elementary school all the way through college. But first, let me just show you what that looks like. So it's just a website, and I'm going to post this right now because I encourage you to play here for a little bit because part of this is a play shop. And I want to encourage you to think about why these tools could be part of your work with your students. So I'm in Wolfram Alpha right now, and you can see it just says, enter what you want to calculate or know about. So I'm actually interested in how many calories are in an Oreo, because I love Oreos, and I'm just curious about that. So think about that. I just asked this database, how many calories are in an Oreo? This isn't a Google search. This is actually using their underlying data set that they have available. So you see the first thing it says, well, I'm assuming you're talking about an Oreo cookie and it's any type of Oreo cookie. I'm going to use one cookie and total calories. So all of this data starts to populate this window, total calories, fat calories, query related to that. So it's pulling up information about Oreos from a database it's got. And you can see I can choose some different types of ones because it said, well, I found these here as well. So when I look at the examples of what I can do, this gets into everything from elementary math. So I know we've got a few elementary math teachers and you're thinking, wait, I haven't really seen anything I like here. But here's examples of ways you can use Wolfram Alpha for elementary math. It can be used for just simple calculations, but it can be used for things like place values. So there's lots of examples built into their website to encourage teachers to think about how you might use this. And then you can see things like, well, what's 1 plus an even number times an odd number, determine the sign. Like there's all of these ways in which you can put intelligent questions, by intelligent, I mean like query questions into this database to get it to help think about what an answer might look like. So you can type in equations into it, you can type in questions, you can type in data sets, and it analyzes them and uses them. And there's a whole structure of supporting resources to help it. Let me show you one quick video that sort of explains that about this. So I want to have you make sure when I play this, you can hear this audio. Please let me know. I'm only going to play a little bit of this. This is Conrad Wolfram. So Wolfram Alpha is actually designed by the names you see there. And so he talks here on this TED Talk about why is Wolfram Alpha so important. I'm going to tell you about it.
We've got a real problem with math education right now. Basically, no one's very happy. Those learning it think it's disconnected, uninteresting, and hard. Those trying to employ them think they don't know enough. Governments realize that it's a big deal for our economies, but don't know how to fix it. And teachers are also frustrated. Yet math is more important to the world than any point in human history. So at one end, we've got falling interest in education in math, and at the other end, we've got a more mathematical world, a more quantitative world than we ever have had. So what's the problem? Why has this chasm opened up, and what can we do to fix it? Well, actually, I think the answer is staring us right in the face. Use computers. I believe that correctly using computers is the silver bullet for making math education work. So to explain that, let me first talk a bit about what math looks like.
And I'm going to stop it there. It's a really wonderful talk, but you saw that first bullet he had, stop teaching calculating and start teaching math. So much of our math curriculum turned into students being calculators. And Wolfram's point and the whole design of Wolfram Alpha is computers can do calculation real well, but they can't think. And so if we let the computers do the calculation, and I'm not saying we don't teach simple addition and tricks for multiplication and all, but that is an end or a means to an end. The end is students applying that mathematics. And so when they have tools like Wolfram Alpha, it provides an opportunity to do that. So I encourage you to take some playtime and play with Wolfram Alpha. One last tool for you, and then we'll open up for questions and conversation. There's a tool called GapMinder. Can I see again if, and I know, Christine, I saw something about 5 calories per cookie. Something wasn't right there, but I'll let you go back and query it one more time and see why that didn't look right for the sake of time. Can I just see a 0, a fist to 5 on if you're familiar with the tool GapMinder? I see 0, 2, 0. So again, let me give you a quick introduction to this. There's a wonderful TED Talk. I'm not going to show it to you, but I've linked it here in the slide deck. Again, this is Hans Rosling, who's passed away, but his son carries on his work. And what he was interested in was how to help people turn data into something visual so that it was beautiful, that it had meaning, that it was able to be used. And so I want to show you a quick example of that and then have you think about how a tool like this could be useful. So this is, I'm going to click right now to take me into GapMinder, and I'm going to give you that link for it as well. So what GapMinder is underneath it, it's a whole set of database. Most of it is from things like the United Nations and from UNICEF and from UNESCO. It's economic data, it's health data, it's global climate data, it's temperature data, it's population. And you can see one of the visualizations, there's many ways you can visualize this data in GapMinder, but the most common one is, here's the 5 continents by color. And what we have here are 2 sets of data, life expectancy in each one of those countries, and you see those countries listed here, and the income level of those countries. And what I'm going to do right now is I'm going to play this for you once, because one of the beautiful things about this is we have data that goes back to the beginning of the century or the previous century. So we can look at what happens over time. So I'm going to play this for you right now from 1800. Again, the red is China, the yellow is Europe and Russia, the green is the Americas, the blue is Africa. Up until 1800, or 1900, most of the countries grouped together. And then you see now something starting to spread apart here over time. But what I want you to see is what happens in these last 20 years. There's been some wonderful things written recently by people like Steven Pinker about we've reached an age where most people think the world is one way, but it's actually not what most people's impressions are. I want to have you actually take a look at this one more time, but this time I'm going to check off 2 countries here so you can track what happens. I'm going to check off China so that it becomes a solid color, and I'm going to check off the United States. And I'm going to replay this, and we're going to just track what happens. We're going to watch all the other countries as well. But in particular, I'm interested in what have the pathways been like for the United States and for China over the last 200 years when we think about life expectancy as a function of income. And let's watch it one more time. So you can see United States is being tracked here. Now it's actually, the dots are staying on there so we can see what happens over time. You can see life expectancy in the United States was at 40, right up until the late 1800s. There was a big drop there. We didn't want to worry about that one. All of a sudden in 1917, watch, whoa, there's another drop there. We might know what that is now with the current world situation. So we see China, income low, life expectancy slowly climbing. And then over the last 20 years, this remarkable thing is happening. And we can do this with every country. What we see is something that's remarkable with this data is over the last 200 years, although the average person lived to be 40 years old, as just as short ago as 200 years ago. Now the average life expectancy, even in these countries that are blue, which we think of as, sort of these developing countries, have now gone up to things like in Cameroon at 64, in Angola at 65. There's been a dramatic change in world health just in the last 20 years. It's hard to visualize that. So one of the things that the GapMinder folks talk about is, I'm going to go back here, is you're probably wrong about all of these things, about global warming, about plastic in the oceans, about suicide, about poor versus poor, because we don't have the data in front of us to analyze and visualize what's really happening. Tools like GapMinder give our students the ability to play with data sets, to make meaning from them, to create graphs and charts and visualizations that expand their thinking and create their ability to analyze and apply their ideas that look at trends and what's happening. I do want to point out one of the things that we've all shown our students here, by the way, is this moment is the influenza outbreak, that the last 100-year one that happened. And you can see in 1918 what that did for life expectancy in the United States just for that one span. We don't yet see the full play out of the 2020 data here because really we're at the tail end of 2020 where that impact became so strong. But once again, we may well see another big drop here if we don't do something dramatic to change the way this pandemic has been playing out. So that's an example of a tool that visualizes data really powerfully for students. So there are lots of resources that are starting to change that are making these kinds of access for teachers to find ways to expand their repertoire of how they design lessons and expose their students to more modeling approaches, more visualization approaches. Can I just check, this is my last check for you right now. The resource you see here is for a website called U Cubed, but it's really the brainchild of Joe Bowler, who's at Stanford. And I'm wondering how many of you are familiar with either U Cubed or Joe Bowler's work, because she has done some of the most significant research on mathematics education in the last 5 or 8 years, I would say. So I see, Mr. H, you've seen some of that work, but some of you haven't. If there was one place I was to encourage you to go today, take a look at the amazing work that she's doing. Her latest book on mindsets and how to create in students the power of being able to take control of their learning and believing they can do. That idea of shifting, I'm not good at math, to I know when I do this, I can get good at math. What are the ways that we can help students develop mathematical mindsets? the work of modeling, the work of visualization, the work of giving students opportunities to play, to do artisanal math, is one of the powerful things that we can do as teachers who intersect with math education, because in doing that, we give students permission to enjoy something that's been really stripped away by making it just about having students learn rote ways to solve problems. So I encourage you, there are 4 tools I showed you today. They're in the slide deck and they're linked. So my goal was to give you some models for what that looks like, to show you the tools. So in that I Teach 808 Math, there's a link. I'll post it one more time in the chat, that the PDF of this is there that has links to all of these tools and to Joe Bowler's website. And I encourage you to think about how you can add, even in small ways, play or modeling or real world applications of mathematics to give your students opportunities to see that math is interesting, math has applied use, that there's reasons why we value mathematical thinking, and that being a bit of a math nerd is a good thing. So I will leave. We've got about 3 minutes before the session needs to end. I want to give some time. I haven't seen many questions in the chat. You're welcome to turn on a microphone if you'd like. I know there's still about 10 of us left in the room here. So are there questions from this that you have? I'm going to stop sharing here, so we're back to just a normal Zoom environment. I see a thank you from Christina. If you would be so kind, I'm going to post, if you're willing, there's a little survey here that I just ask you, how did this help? And one of the things on this slide deck is this resource folder. So while I'm waiting for questions to come, I just want to show you, if you go to this resource folder, there's readings on rethinking math. There are images of student work from some of the things I had, a much more expanded library. Lots of math, so like here in the math activity examples, these are all different kinds of activities that I had been doing with my students as a means to get them to think about how they might apply mathematics in interesting ways. And then there's a few places here that have activity ideas. So you're pleased, this is available for you, and you can come in here and take a look at any of these. You can reach out to me. I'll put my email address in the chat, but you can also find me if you just look at Mid-Pacific or Kuplo Ho. And I always love to chat with math teachers about ways that we're trying to challenge ourselves to provide authentic math experiences for our kids. Well, I think we're out of time, but we're not out of ideas. So I hope you stay in touch. Thank you so much for being here at the end of the day. And hopefully you got something that will challenge you and excite you to play with math some more. Thank you.
Thank you, Mark, for sharing your knowledge and your wisdom. I see one of the last comments was Marla's going to share it with her math and science department. That's great. I often think, I wish I would have learned math in this way. I'm a librarian. I ran away from math, but yeah, it's great to see, teachers out there approaching math in such a fun and visual way. I think it's awesome. Yeah. So thank you once again, Mark. Thank you, everybody, for participating. And we'll send out a session evaluation to your email in about a week or so. Yeah, so thank you, everybody. This concludes today's session. Okay. Everybody take care.